Hello students, welcome to my YouTube channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of the series on online electronics laboratory, and in this part we'll discuss the lab exercises on signal generators. The assignments in this part includes the oscillators. Here we'll cover both RC and LC oscillators. In multivibrators, we'll do experiments on all the three multivibrators: bistable, monostable and astable. And we'll see the working of 555 timer as monostable multivibrator and as astable multivibrator. The next assignment is LC oscillators in this series of oscillators, and this experiment is performed on this kit. You can observe that on this kit we have all the oscillators connected. We have Hartley Oscillator, RF tuned oscillator, Colpitts Oscillator, then we have Crystal Oscillator, we have Clapp Oscillator, 20 oscillator we have already seen. With the help of these two switches we select either 20 or Clapp Oscillator. Then we have this blocking oscillator here. Then these three multivibrator circuits are also given, and this is the switch with the help of which we select one of the oscillators, and switch position decides which oscillator will give us the output. So let's do the experiment. Let's see the kit on which we will be doing oscillator experiments. It contains all the oscillators, Hartley and RF tuned oscillator. Then it has Colpitts Oscillator, Crystal Oscillator. This is the blocking oscillator, then Clapp or 20 oscillators, and then three multivibrator circuits are there to see the functionality of these multivibrators. The switch is provided to select one of all the circuits. So we have to select through the switch and then we have to observe the frequency on the CRO. So we have selected the first switch and it is set at Hartley Oscillator. So let us observe the waveform for Hartley Oscillator. And you can observe here the amplitude is approximately 4 volts and the time division setting is 1 microseconds, and it is taking approximately 2.4 divisions here on the time axis, that is on horizontal axis. So thereby we can calculate the frequency using this time period here. The next is tuned oscillator. Tuned oscillator, the amplitude is little less. You can observe here amplitude is approximately 1.5 volts or so, and the time period and the frequency is exactly same as Hartley oscillator. Coming to Colpitts Oscillator. The Colpitts Oscillator, the component values are given, and let us observe the output waveform. We have to change the switch to Colpitts to get the output, otherwise it will not show us output. And you can see here the time period is more here, that is the frequency is less. 100 microsecond time period is set and it is occupying approximately 2 divisions on the time axis, and amplitude is approximately 3 volts. The next is the crystal oscillator. A crystal of frequency 3.57 megahertz is connected in this circuit. So definitely the frequency is going to be quite high here, and it is observed on the CRO. We have to change the switch to crystal oscillator, and here we are. Time is set in nanoseconds now. You can see here the number of divisions for 100 nanoseconds. At 100 nanoseconds, we will calculate the frequency. Coming to the Clapp oscillator, presently it is set to Clapp oscillator, and the frequency, the time period is in microseconds again. So we have set it to 200 microseconds, made it to 100 microsecond, and 2 divisions at 100 microseconds in Clapp oscillator. Coming to blocking oscillator. In blocking oscillator, it is used for the lamp, as you can see. So it's not going to give us sinusoidal waveform. A transformer is used, and you can see the voltage. I have set it to 20 volts at the, so it is approximately giving us a voltage of 12 volts. As the lamp is of 12 volts 2 watts power. So we need to give 12 volt supply to the lamp so that it can glow. In this LC oscillator experiment, we have observed all these oscillators and we have observed the waveform and we have calculated the frequency for all the oscillators. Like for Hartley oscillator, the one cycle took 1.2 divisions and the setting of times per division was 2 microseconds. So the time period obtained is 2.4 microseconds. And this gives us a frequency of 420 kilohertz and the voltage level was 2.5 volts peak to peak. The tuned RF oscillator, the frequency was same. The voltage obtained was slightly less. It was 1.5 volts peak to peak. Coming to Colpitts Oscillator, the frequency obtained is 4.54 kilohertz and the amplitude was 3 volts peak to peak. For Clapp Oscillator, which is the modified version of Colpitts Oscillator, the frequency obtained is 5 kilohertz and the amplitude was 3 volts peak to peak. Lastly, we have seen the Crystal Oscillator. The crystal which was connected in the kit was having a frequency of 3.57 megahertz and we observed the same frequency on the CRO also. The amplitude observed is 2 volts peak to peak. Now you can see these theoretical values. These values are calculated based on the components which are used in the circuit, and these are the practical values which are the actual values obtained from the CRO. And you can see the difference between the two. Like we have 500 kilohertz here, obtained value is 420 kilohertz. We have 4.3 kilohertz and obtained value is 5 kilohertz. So this difference of theoretical and practical value is because of the components which are connected in the circuit. The components have tolerance, which means that their value which is written on the component or which is given for the component is not true. There is a slight variation in the component values and this results in the change in the practical frequency. Additionally, the instruments which are used in the lab, at times they are not calibrated, so that also results in the error in the calculation of the frequency. I hope you have seen the outputs of all the oscillators, how the frequency and amplitude is calculated on the CRO. Thank you.